Okay. 2.7, using absolute value functions and transformations. So, remember how I told you that we have parent functions for all the graphs that we have? How we have parent functions? Okay, so we're going to talk about absolute value and its parent function to start with. So, absolute value. Okay, the parent function for the family of all absolute value functions is f of x equals the absolute value of x. It's important, so I have to be very careful. So it's f of x equals the absolute value of x. That's your parent function. Which means if I plug in a 0, I get a 0 out. That's my vertex. Absolute value is always going to make a v. Okay? The diagram or your graph will always be a v because you have a positive and a negative input for absolute value. Yes?
Yes.
Okay, so it's like a reflection. So if I plug in a 0, I get a 0 out. That's my vertex on my parent function. If I plug a 2 in, I get a 2 out. If I plug a negative 2 in, I get a 2 out. And then I can graph from those 3 points. So I only really need 3 points to graph. I need a vertex and then 2 inputs, okay? The highest or the lowest point on the graph of an absolute value function is called the vertex. So this right here is my vertex on the parent function. It's 0, 0. Okay. And so that's what this is. So when you are graphing absolute value, it's very important that you find where the vertex is located first. From there, I can plug things in. And we're going to talk about what shifts and stuff look like. Next switch.
What all are we supposed to write on here? Everything?
Well, I would just write the parent functions graph and then make a rough sketch of it and label the vertex at 0, 0. And then you know if you input a 1, you get a 1 out. If you input a negative 1, you get a 1 out. And you just make your V. Yes?
So you're saying the vertex could also be like it was flipped and that was on top, then that would be the vertex? If it says highest, then like...
Yes. So my graph could face down if what's in front of this absolute value sign is a negative. Okay? And we're going to look at something like that too. So yes, Mallory, good observation. Yes? Today? No. Oh well. I'll get it. I'll get it. So that is the standard form of an absolute value function. Okay, the parent function. Now, here's what happens, okay? So translations can happen to functions. Just like translations happen to linear functions, they can happen to absolute value functions. So the parent function here is in blue. It's y equals the absolute value of x, okay? The vertex is at 0, 0. My graph goes straight up. Now, you can have something where you subtract an h on the inside and add a k to the outside. H, okay? The h always goes with my x-axis, or is my x point. And the k is always my y point. So that's where I get my vertex from. My vertex is my h and my k. Okay? So in this case, the reason the parent function is 0, 0 is because there is no h and there is no k. Does that make sense? For your vertex? Okay. We're going to shift these graphs.
So that's an equation for transformation.
Yeah, yes, it's a transformation that's happening to it, yes. Okay, so just like when you have quadratic functions and you shift them or do things, I think you guys have done stuff with quadratics, you got to remember back though. Okay, the h and k tells me what's happened. So if this is minus h, the normal standard equation always says x minus h in the absolute value sign plus k. Whatever h is, it's opposite when you're doing it. But y stays what it is. So if y is negative, y is negative. If k is positive, y is positive. If h is negative, x is positive. If h is positive, x is negative. And that's my vertex point. So that's my starting point of this graph. Okay? The transformation changes a graph's size, shape, position, or orientation. And a translation is a transformation that shifts a graph horizontally and or vertically. So yet last year in geometry you did lots of translations and transformations with shapes. That's what we're doing to graph these things. Okay? It's the same concept as in geometry with translating and sliding things or moving things up up and down. Okay, so the graph y equals x minus h plus k is the graph of y equals the absolute value of x. This is just the parent function. And this is the transformation, or the translation, okay? So it's translated h units horizontally and k units vertically, which gives me this, the vertex and then hk. And we can relabel it as xy. So we're going to turn this into a graph, because I just put a grid in here because we didn't have graphing things on this. Okay, so let's graph this. We want to graph y equals the absolute value of x plus 4 minus 2. So the first thing I need us to identify is where is my vertex? So what would be my vertex off of this? 4. Okay, almost. It's not 4, negative 2, it's
Negative 2, 4.
negative 4, negative 2. Always opposite of what that is. So my vertex is negative 4, negative 2. Okay, so I'm going to go to negative 4, negative 2, and I'm going to graph a point. When I go to negative 4, negative 2, I now know that that is my vertex. So I'm actually going to count these by 2 since I don't have a lot of space. So negative 4, negative 2 would be here. Here's my vertex. Now, to get my other points, I literally just pick a number and plug in here. So I'm going to pick 1, because 1 is easy to plug in. If I plug in a 1, I have the absolute value of 1 plus 4 minus 2. So I have 5 minus 2, which gives me 3. So my point is 1, 3. So I come over here to 1, and I go up to 3, and I graph a point. Now, that point, oops, that's not 3, is it? That's 4. I lied. I go to 1, and I go to 3, and I graph a point. Okay. Now that point is technically what? I can do what with that point? Do I need to plug another number in? If I plug in negative 1, what do I get out? What?
I don't know, I have a question.
Okay, what's your question?
Where did the 1 come from?
I just pick a number and plug it into x.
Oh.
You have to pick a number. That's step 2. So step 1 is graph the vertex. Step 2 is pick a number and plug it in.
So no matter any number.
Yeah, I would start with something very easy if you can. You get what I'm saying? So that's why I picked 1. And then 1 plus 4, the absolute value of 5 is 5. 5 minus 2 is 3. That's my point, 1, 3.
When you get different answers though than other people if you just pick any number?
Yes, but your graph should still come out to be the same. Because if I pick the number negative 2 and plug it in here, I'm still going to have a graph that goes out like this, the same width. Okay? It's all about how you graph. So yes, you can pick different numbers than your neighbor. If I have this point at 1, 3, that means that this right here, my vertex, is my axis of symmetry. Okay? Which means this point would reflect over this axis of symmetry, okay? Over that symmetry, that line of symmetry, to create a point on the other side because it is a V in its absolute value. So I know if I have an input on this side, it reflects to the other side. So I don't even have to put in another point. I can just reflect this point over that line. Does that make sense to get my graph? So if this is at 1, 3, okay, then it's 1, 2, so it's 1, 2, so it would be here, right? Yeah. So my point would be there, and then I can draw my graph off of that. And now I have a graph of that equation. Does that make sense? Okay, graph the vertex first, then plug a point in and reflect it over. What, Mallory?
Does that have to be the same, like, spots over from the axis of symmetry?
Yes.
on both sides?
Yeah, so like
wouldn't it
this
be one
is
more over?
2, 4, right? 2, 4 is where it would be. 4. So it would be, what?
So you don't count the one in the box.
Well, this is because this is on a 1, right? So 1, counting by twos on my graph, yes? So this is, at 1, and then to 0, and then to 1, so 1, 2, 3, 4, it's 5 points away. 1, 2, okay, I guess I can go right. So 1, 2, 3,
Do we?
4, 5 points away, like that. Okay. So it's y. Okay, so there's your graph. You can plug in other points if you want to, but you don't have to.
Wait,
What?
okay. So, 1 through -4 to, how you get -4?
How do I get -4? Because this tells me that it should be negative instead of positive. My
Oh.
vertex is the opposite here, but the same there.
So that
Opposite,
was,
same.
it was y equals x plus 4 plus 2.
Then it would be -4, +2 would be your vertex. This always stays what it is. This is always opposite what it is.
No, but now, you got it. So, that's 130, that's still 130?
This is -4, -2.
Then that's 130.
And then this is 1, 3.
So then,
So that this point was reflected over this axis of symmetry to get the next one so that you can make your V. Okay? Okay. Glad you can look at that. Okay. So with those things, you can stretch, shrink, and reflect graphs. Stretch, shrink, and reflect. Okay? When the absolute value of A does not equal 1, the graph of y equals A times the absolute value of x is a vertical stretch or vertical shrink. So you are stretching and you are shrinking something when there is something being multiplied. Oops, I marked it. When there's something being multiplied. When there's something being multiplied on the outside of that absolute value. So the outside of the absolute value, what's multiplying into it, tells me if it's stretching or shrinking. Here's how you know what's going on. If the absolute value of A is greater than 1, the graph is vertically stretched or elongated. So I'm stretching it out. Okay? Which means my graph becomes more narrow, because if I stretch something out, they get tall and skinny. Okay? It becomes more narrow. If my absolute value of A is less than 1, the graph is shrinking, has shrunk, or compresses, so it's getting short and fat. Okay? So, if I have a number in front, this represents my A right here. This 1/2 represents my A. Okay? If that's my A, is my graph shrinking or stretching according to that number? It's shrinking because the number is less than 1. So it's shrinking, which means my graph should become short and fat. Okay? Instead of stretching out, it's going to become shorter and fatter. Stop. So you're going to have to do a lot of this stuff on your homework where you are going to compare your graph to its parent function. Okay? So if it says graph y equals 1/2 absolute value of x and y equals -3 absolute value of x. Now, what type of number is happening here with my A? Okay, no. Here's why, Tyler. It says if you take the absolute value of A and it's less than 1, you're shrinking. If I take the absolute value of -3, what do I get? 3. So is it shrinking or is it stretching? It's stretching, okay? The negative tells me something else. This negative tells me that this graph is going to flip down. That's what Mallory asked about earlier when she said, it says it can be the top or bottom, okay? So it's going to flip down. That's what the negative tells me. So I'm going to graph 3 things on this graph, okay? We're going to start with, let's actually start with the parent function. Let's graph this first. What do we know about the parent function? Where's the vertex? No, where's where's the vertex of the parent function, of the original graph? What? 0, 0, because there's no h and there's no k. So this is my vertex. And then if I plug a 1 in, what do I get out? 1. If I plug a 2 in, I get 2 out, okay? We're going to make these count by 2's again. So that's going to be 1, that's going to be 2. Okay. So if I plug a 1 in, I get a 1 out. We're just going to make this go like this. Plug a 1 in, I get 1 out. Here's my parent function. Okay, does that make sense? A parent function. Can you handle that? So there's my parent function. Now, let's graph y equals a half absolute value of x. Is there a different vertex? Do I have an h and a k? No, no, Lily says no, there's nothing added to this x, there's nothing added on the outside of this. Okay, so what does that mean my vertex is? 0, 0. So we're gonna make this one red. So my vertex is still 0, 0. But now I have a 1/2 in front. So if I plug a 1 in here, what do I get out? If I plug a 1 in, what's the absolute value of 1? And then what's 1 times a half? 1 times a half is 1? 1/2. So if I plug a 1 in, I'm going to get the point a half out. So if I plug a 1 in, I get a half out, which means my graph goes here. And my graph goes here. Now, this graph should be shorter and fatter, is it? It's getting wider. Okay? It's shorter and fatter. What?
So what's the blue graph again?
The blue graph is the parent function. This one right here. What? What's just 0? What? What is 0?
Is the parent function?
No. The parent function is y equals the absolute value of x. Its vertex is 0, 0. But then you plug any number in and you're going to get the number out. 1, 1, -1, 1, 2, 2. What do you mean, where do you get y? When you plug something into x, you get what comes out for y.
Well, if that equals.
Okay. Now, let's look at this graph too. We're going to graph this one. Y equals -3 absolute value of x. What is my vertex? 0, 0. Lily says it's 0, 0 again. She is correct because there has been nothing added to x. There is no h, there is no k. What does this negative tell me?
It's going down.
It's going down. And the 3 tells me that it's going to do what?
Bigger.
Is it going to stretch or shrink?
Stretch.
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 Stretch. So if I plug a 1 into here again, I plug a 1 in, what point do you get out? The absolute value of 1 is?
-1.
1.
One.
And then
Let's
1
get it.
times -3 is?
-3.
-3.
I was kidding.
So my point is 1, -3. So if I go to 1 and go down to -3, I can put a point, well, if my board would read it. And if I go to -1 and put a point at -3, now here, oh, I can't see to do this, is my graph. Okay, now you see how that one gets more narrow and skinnier, okay? Those are things you're gonna have to do on your homework. Now, you can compare all of them by graphing them all on different graphs and labeling them, or you can put them all on one graph like I just did with different colors. It's up to you, okay? Most of the time people use different colors, it makes it easier, and you can visually see it. They're also going to ask you to compare things in words. That's why I'm asking you, what changes here? This shrinks by, or this, not shrinks, this stretches by 3 units, making it skinnier and longer, okay? It's also flipped down because there is a negative in front. The red one shrinks by a 1/2 unit and it gets shorter and more compressed. These are the things you're looking at, okay? Here's another one. we're gonna compare the first graph to the parent function, okay? So if I were you, I always start by graphing the parent function first, because I just think it's easier. We're gonna pretend like this is perfect all the time.
Wow, that's a pretty perfect
I know,
line.
it's beautiful, right?
You're so good.
I'm gonna put extra lines in here so that I can use stuff to graph.
Chart class too.
Okay. So where does my parent graph start? We're gonna do it in red.
0, 0.
It starts at 0, 0 is my vertex. Then what happens?
Plug in one.
Plug in 1, what do you get out?
1,
1, 1. So I have a point at 1, 1, and I have a point at negative 1, 1. Here's my parent function. Okay? Now, let's graph this. What is the graph of y equals negative 2, absolute value of x minus 1 plus 3? Start with the
-1.
vertex. What is my vertex? What is my vertex? 1, 3. Opposite of that, this stays the same. My vertex is 1, 3. 1, 3. 1, 2, 3. There's my vertex. Okay? Now what do I need to do to it?
Plug in 1 for x.
Plug in 1 for x. Okay, so if I plug 1 in for x, I have this. What is 1 minus 1? 0. What's 0 times negative 2? 0. So then I have a 3 as my output.
Are you not sure?
So what you get is 0, 3. Okay, that works. So here's 0, 3. Wait, I lied. Here's 0, 3, right? That's not gonna work. I can't plug in a 1. I can't have a 0 in that absolute value spot. Okay? So you can't plug anything into the absolute value spot that's gonna give you 0. So let's plug in a
2,
2.
3, 4.
Let's plug in a 2. Let's just do 2.
100.
Okay? What is 2 minus 1? 1. Absolute value of 1 is 1. 1 times negative 2 is
Negative 2.
negative 2. Negative 2 plus 3 is
1.
1. So if I plug in a 2, I get a 1 out. If I plug in a 2, I get a 1 out. Now, would this make sense? Should it be facing down? Well, what tells me if it faces down or not? A negative. Is there a negative?
Oh.
Yeah. So this makes sense. I'm facing down. It's, okay, here's my line of vertex, my symmetry. So I am 1 unit away from there. So 1 unit away from there would be here. So this is my graph. I'm sorry, it's because I'm on a board that hates me.
No, I'm just talking about the lines.
Is this from downstairs?
Scissors like that's terrible.
No. Where'd you get it? From Holmes. So that is how I graph that. Does that make sense so far? It takes steps, it's just steps. Find the vertex, plug in a point. You cannot get 0 in the absolute value, it won't come out right for you.
Can you do that there?
Can what?
Can you do that there, so I can just-
Yeah. I didn't hold this schedule. I don't know, he had one and then he didn't like it. We're gonna stop there today, and we're gonna do more of this tomorrow. Okay?
So was that graph wide?